What if I told you that glaciers can steal from each other? Not metaphorically, not over thousands of years. Scientists have watched one enormous Antarctic glacier redirect ice away from its neighbor in less than 2 decades. It is called ice piracy, and it could change what we thought we knew about Antarctica, rising seas, and how quickly an apparently frozen world can reorganize itself. This is EXEPEL, and today we are traveling to one of the coldest, most remote places on Earth, where a silent robbery is happening beneath our eyes. From space, Antarctica looks almost motionless. It appears to be a permanent kingdom of white, frozen in time. But this is an illusion. Antarctica's ice is constantly moving. Snow falls in the continent's interior, becomes compressed into ice, and slowly flows downhill under its own enormous. This moving ice eventually reaches the coast, where it enters the ocean or breaks apart into icebergs. A glacier is not simply a mountain of frozen water. It is more like an incredibly slow river. Most of the time, its movement is too gradual for a person standing nearby to notice, but satellites can watch the same glacier for years. They can measure tiny changes in its speed, height, and direction. And when scientists compared years of satellite observations from West Antarctica, they noticed something extremely strange. The Polar East Glacier appeared to be pulling ice away from its neighbor, the Polar West Glacier. The boundaries separating their ice flows had moved. Imagine 2 rivers flowing side by side toward the sea. Then, one river begins deepening and accelerating. The slope of the surrounding landscape changes, and water that once flowed into the second river begins turning toward the first. Now imagine that happening with billions of tons of ice. That is essentially what scientists observed. Polar East had accelerated. As it moved faster, its surface lowered. That created a change in the slope of the ice sheet. Ice that would normally have flowed toward Polar West began being redirected toward Polar East. One glacier was capturing part of another glacier's supply. Scientists call this process ice piracy because it resembles one river stealing the drainage area of another. In geology, rivers can change course and capture water that once belonged to a neighboring river system. But discovering a similar process happening between modern Antarctic glaciers was remarkable. The most shocking part was the speed. Changes of this scale were once expected to unfold over centuries or even thousands of years. Yet satellite measurements showed that this major reorganization happened in less than 18 years. For a human city, 18 years can feel like a long time. For an Antarctic ice sheet that has existed for thousands of years, it is almost an instant. But why did Polar East begin moving faster? The answer lies far below the glacier, where the ice meets the ocean. Much of West Antarctica does not rest safely on dry land above sea level. Parts of its enormous ice sheet sit on bedrock located below the ocean's surface. Around the coast, floating ice shelves act like giant barriers, slowing the glaciers behind them. Think of an ice shelf as a doorstop holding back a heavy door. The shelf does not completely stop the glacier, but it resists its movement. When warmer ocean water enters beneath an ice shelf, it melts the ice from below. The shelf becomes thinner and weaker. As its resistance decreases, the glacier behind it can begin flowing faster toward the sea. This appears to have contributed to major changes in the region. Polar East accelerated and thinned more rapidly. As its surface became lower, the surrounding ice slope changed. Gravity then began directing more ice toward it. The glacier did not decide to steal. Gravity did the stealing for it. And once the process begins, it may reinforce itself. A faster glacier can become thinner. A thinner glacier can alter the slope. That changing slope can attract more ice from neighboring areas. More incoming ice may then feed the faster flow. It becomes a slow-motion chain reaction across a frozen landscape. But why should anyone living thousands of kilometers away care about one glacier stealing ice from another? Because Antarctica contains enough frozen water to transform coastlines around the world. Not every change in ice flow immediately raises sea level. Floating ice is already displacing water much like an ice cube floating in a glass. But the ice resting on land behind it is different. When that land-based ice enters the ocean, it adds new water and raises global sea levels. Ice shelves help control how quickly that land ice can escape. If the glacier receiving stolen ice carries it toward the ocean faster than the glacier losing it would have done, ice piracy could increase the rate at which Antarctica loses mass. This does not mean one event will suddenly flood the planet. The real concern is that our models must correctly understand how ice moves across the entire continent. Scientists often divide ice sheets into drainage basins. Each basin represents a region where ice flows toward a particular glacier or a section of the coast. These boundaries may look fixed on a map, but the discovery shows that they can move. A glacier can expand its drainage territory and capture ice from its neighbor. The amount of ice flowing toward different parts of the ocean can change much faster than previously expected. It is almost as if the rivers, valleys, and borders of an entire hidden continent are being rearranged, even though everything above them appears frozen. And Polar East is not the only glacier behaving strangely. In the same wider study, scientists examined several glaciers across West Antarctica. Some had accelerated dramatically, while at least one showed unusual slowing and thickening. That is important because Antarctica is not responding to climate change as one simple block of ice. Different glaciers react differently depending on the shape of the bedrock beneath them, the depth of the ocean nearby, the strength of their ice shelves, and the routes taken by warmer water. Two neighboring glaciers can experience completely different futures. One may accelerate, one may slow down, and one may begin capturing the ice that once flowed toward the other. This makes predicting sea level rise much more difficult. Scientists cannot simply ask how much ice Antarctica contains. They must ask where that ice is moving, how quickly it is moving, which barriers are weakening, and whether the boundaries between glacier systems are shifting. To answer these questions, researchers use satellites that repeatedly pass over the same region. Radar instruments can observe the ice even through clouds and during the long darkness of the Antarctic winter. Scientists compare images taken at different times to calculate how far features on the ice have moved. Other satellite measurements reveal changes in surface elevation. If a glacier's surface becomes lower, it may be thinning. Gravity measuring satellites can also detect changes in the total mass of ice across enormous regions. A person standing on the glacier might see nothing unusual, but from orbit, the robbery becomes visible. Lines move, speeds change, surfaces sink, an invisible border migrates across the ice. This is one of the most powerful ideas in modern Earth science. Our planet can change in ways too slow for the eye, but shockingly fast on geological timescales. A glacier does not need to collapse dramatically for something important to happen. Sometimes the warning appears as a barely visible shift in direction. And the discovery raises an unsettling question. If an enormous Antarctic drainage system can reorganize itself in less than 18 years, what other changes have already begun but remain hidden beneath the ice? There are vast areas of Antarctica that are difficult to observe directly. Beneath kilometers of ice are mountains, valleys, lakes, sediments, and channels through which water can move. The frozen surface hides an entire landscape. Small changes beneath that surface may redirect enormous quantities of ice above it. This means Antarctica is not merely melting around its edges. In some places, its internal traffic system may be changing. The roads followed by ancient ice are being rewritten, and when one route becomes faster, it can pull material away from another, just as a growing city can redirect people, money, and resources away from its neighbor. The difference is that the resource being redirected here is ice, and its final destination is the ocean. Ice piracy sounds almost impossible because we imagine glaciers as dead objects. But glaciers respond to gravity, pressure, heat, friction, ocean currents, and the shape of the Earth beneath them. They stretch, crack, accelerate, slow down, merge, and sometimes capture each other's flow. They are not alive, but they behave like dynamic systems. That may be the true mystery of Antarctica. The continent looks silent, simple, and still. Yet beneath that white surface, it is constantly negotiating with gravity and the ocean. Its borders move, its rivers of ice compete, and sometimes one glacier steals from another. So the next time you see a peaceful image of Antarctica, remember that you may be looking at one of the most active landscapes on Earth. A landscape where a robbery can involve billions of tons of ice, last for years, and remain completely invisible until satellites reveal the evidence. What do you think? Could ice piracy make future sea level rise more difficult to predict? And what else might be happening beneath Antarctica that we have not discovered yet? Share your thoughts in the comments. And if you want to uncover more strange scientific discoveries that sound impossible but are completely real, subscribe to EXEPEL, because the most mysterious stories on Earth are not always hidden in ancient ruins or distant galaxies. Sometimes they are happening right now, silently, beneath the ice.